All right. So first of all, once again, thanks a lot for attending my session and welcome. And my name Olena Borzenko. You can find me on Twitter. If you have any questions or comments, please feel free. Don't hesitate to text me. And a small introduction about me, what I'm doing, my company. I'm senior backend engineer in a company called Express. It's a beverages delivery service based in Germany. And currently we are in process of merging with another company, which used to be our main competitor on the market because they are doing the same business. So as a result of this merger, a decision was taken to build a new warehouse system. And basically the idea for this talk was born out of my daily work, as I'm part of this team, of the warehouse team. So as we implementation is going further in our new system and we are getting more and more requirements, we had a lot of discussions what kind of features we might introduce later on in our system. And I decided to take the already kind of the structure more or less we have and try to integrate other Azure features in it and see how it works. So that's what I want to share today. And before going into technical details, I want to say a couple of words about the warehouse system itself, so it will be pretty clear what I will show during the demo. So the warehouse, it's just a box, that's kind of a reality of the life. It's just a buffer between the supplier and our final customer. And there is, of course, the whole science behind it, how to build a nice warehouse system, and even how to build the physical building, how it could be structured, and so on. But there are some kind of fundamental things which exist kind of in any warehouse. So the first of all, it's a movements, as they drive all the physical processes inside. You want to know where's your current products, what's the amount of products, how they are moving inside. And based on this information, if you're able to track all those events, you will be able to easily calculate at least two things. Of course, much more, but we will have an example. We will see the example of two things. The first of all, if you have the right amount of stock. So what it basically means that we want to know if you have a right amount of products, not only in positive numbers, like physical items in there, but if we lost something, if some products were maybe broken, maybe missing during the transportation, maybe an accident happened or whatever. So we want to be able to see all those reports, how many items we sold, how many items do we have, and what happened with the rest. And having all those events, basically the history of everything that is happening in warehouse, it will be really easy to aggregate and get this information. And another thing is if our stock is basically in the right place. And as I said before, the structure of the warehouse could be really complicated. And for example, you can have a 3-zone in a warehouse where your products, like fast-moving products, mid-moving products, and slow-moving products. And depends if your items are in the right place, it has a great impact on efficiency and how those items are delivered to a customer. So this is really important to know the state of your warehouse, what is happening on your physical locations. So while we were discussing all those details, how all this should work, how we can track all those movements and later on calculate all this information, we kind of after some time decided to try Azure Cosmos DB. As we already saw from title, we will work with this a bit more later on. And we decided to use Cosmos DB, and we got this idea that it will be really easy to use it if we will also have Azure Functions. So every time when there is a movement happening in the warehouse, like employee coming to the crate of products, scanning it and moving from one place to another, or maybe if it's automated warehouse, the robot will move those items, we will call our Azure function and we will save this information in Cosmos DB. And all right, so we have a persistent data store. Now we have all our information, and what next, how we can calculate it. Usually with the traditional databases, I will just write some queries, I will start pulling data out of it and do all those calculations. But Cosmos DB has an amazing feature which is called change feed. Maybe some of you already heard of it. The benefit out of it that using different Azure functions, for example, or other ways, you can pull the data out of it, or you can subscribe on a specific containers and listen to every change which is happening inside your Cosmos DB. So we decided that we will introduce a couple of Azure functions which will listen to a specific container, which is in our case movements container. And every time when there is a change happening, we will update the state of our warehouse. So we will generate materialized views with information of what is happening on our physical locations. And also we will calculate a stock. So we will find out how many articles do we have and where are they located currently. And later on, we will save all this information back in Cosmos DB, but in a different containers. So while we were designing this part, it was like initial step, basically. I realized that this is really, really flexible because as like Lego bricks, you can take all those Azure functions, you can combine it and like build different functionality for different part of the systems. And I'm really big fan of Lego, as some of you might see on my background, I have quite a lot of cars. And I really like when it's like, when you have this flexibility and simplicity of building it. And also find out that I'm quite lazy of writing a lot of code. So every time when I can just take and use something, I'm really happy out of it. So the next step, logical for us, as we already have all this information, we want to have a stock monitoring. Or if any of you ever been to any warehouse or maybe worked in any product company, there's like it will be a usual thing to have many different dashboards like monitors where you can see how many orders are coming in, or how many products do you have, or how many cars are available or employees are available to do some work. So for warehouse systems, monitoring is a really important part. And I was thinking like how we basically can introduce this monitoring functionality easily, not creating, you know, some like bicycles or whatever. So as we saw in the previous structure, like we already had this step when we knew how to calculate our stock and also like to know the state of warehouse. But taking like this small piece, like what else can we do, how we can then like show all this information in real time, or just like give those updates pretty often, so the information always will be current. So I decided that I will just do exactly the same thing as I did before. I will subscribe on a change feed for the different container, which is stock per location in this case. And because Azure functions have a lot of like different bindings and triggers, we'll get to it a bit later. I can easily connect to Azure SignalR service and send my messages there, and they will be broadcasted to any of my clients. So basically, the result was like playing around with change feed, Azure Functions, Cosmos DB. What we achieved that we can create many different materialized views and show exactly the information our like employees or like maybe our clients want to see on a specific dashboards, not mixing all this and not overwhelming with the information like specific screen. So this was really great achievement for us. And I also found out that it's like super simple. Again, I can take already what I did before, just combine it in a different way and achieve completely different result what I want. And this is simple because every other developer which works in the same system will recognize the patterns. Okay, I have a change feed, and again, I have an Azure function. So this will be kind of a building blocks, and the only information which will be new for our developers is business logic itself, because the rest is the same across the whole system. So as I said already a couple of times, Cosmos DB and change feed, I also might realize that not everyone used to work with this. So I will use a couple of minutes just to say a bit more about change feed itself. So the Cosmos DB has containers, and we can compare it as like normal tables in, like, for example, Azure SQL. So those containers, they will have documents, they will save the documents with our information, and we can go in there and update document or create more documents. But the change feed will save all those events, every write or update operation, as a separate document. So we will have a complete log of everything that is happening in our system from the very beginning. And the great thing is that we can also consume all those events from any point of time or from very beginning. It's up to us. And there is a couple of ways how we can do this, basically. So we saw already that we can use Azure Functions. What we can do also, we can implement, if we cannot, for example, if you don't like Azure Functions, if you don't want to use it, we can also implement change feed processor using change feed processor library. We can do this on our own, subscribe to a specific container and listen to changes. And every time when there is a write operation or update operation happened, those changes, those events are going to be pushed to us, and we can handle them in the way we want. But of course, in this case, you have to do a bit more work because you have to deploy it and handle like all the other things. So another way is you can manually pull all those events from change feed. And this is like, I would not do this for the everyday work. If I would need to migrate all my data from Cosmos DB to another data store, I will definitely go with pool model, because then I can extract all the events and process them in the event I want. But this is really complicated way, because in this way you have to handle everything: the state of the change feed, the exception handling, the way how you like deploy it. Everything is on you. But it's also really, really useful model how to consume those events. And of course, because Cosmos DB is part of Azure, you can do a bit more with this. So as I already said, you can trigger an API on every update or insert. So you can use Azure Functions to do something, or Event Hub to process those events. And also you can do real-time stream analytics. So as I started to work in the warehouse, it's not new that usually like a business might request some numbers, reports, or like tons of reports. So it means that you, at some point of time, you will need to do some heavy aggregations. And because Cosmos DB is not exactly it's not exactly for those like heavy queries and those aggregations. So there are some built-in functions, but I would not do this to build a report, for example. I was looking into other potential solutions, and I found out that Cosmos DB has a connector for Apache Spark, and you can do real-time heavy aggregations, which was a great thing for us. And as already mentioned, a zero downtime migration of your data in another data store, as for example, Data Lake or Cosmos DB as well, or maybe Azure Storage Blob or Table. So it's just like, I just wanted to give a general overview on Cosmos DB and change feed, because this is kind of important to understand to understand it later, how it will generate some movements and how we'll see those real-time updates. And going back to our Azure functions, like because we will use them quite a lot, I want to also make it clear that Azure function itself, it's not an independent unit. The function up is the independent unit of development and deployment. And inside this app, you can have many different functions. So I would think of it as a different method or endpoints in your regular like application, and the function app itself can be represented as a microservice. So the function app can have different triggers and bindings. And today we will have a look on the combination of some of them, and we'll have a look how the HTTP trigger and Cosmos DB trigger works. And also we will have a look how the Cosmos DB input and output bindings and SignalR input and also output bindings works. And just to give a bit of also understanding, every Azure function can have only one trigger. It's no matter which one, like if it's like HTTP or Cosmos, but only one trigger. But in the end, you can have as many bindings as you want. If you have input binding, it means that data will be pulled in at the start of execution of your Azure function. And if you have output binding, your data will be pushed out in the end of the execution. So I want to give a couple of examples how we can combine those triggers and bindings. And we will have, during the demo, we will see in total 5 different Azure functions. So the first one will be, is to create a movement. I will just generate random movements so we can see how the real-time works and the creation of those materialized views. And for this, I'm using HTTP trigger and Cosmos DB output binding. So what it basically means that I will, with the output binding, I will use a database named warehouse and a collection name, or otherwise container, which called movements. And then I will build my some test data, and I will add it to async collector documents out. And when my Azure function will finish execution, it will push automatically this data to Cosmos DB. When this data will be generated and pushed in Cosmos, we have another Azure function which will react on those changes. And this function will calculate our stock. So I will subscribe on this on the same container as before, on the movements container in warehouse database. And every time when there is update happening or change, I will this Azure function will be triggered, and I will do some execution in it. As I will transform my data, I will build the materialized views, and I will save it back to Cosmos. And because I want to be able also to receive this information from my client, I'm using HTTP trigger and Cosmos DB input binding. So when I will trigger this function, I will receive everything what is in stock per location container. And we will see later on that there will be 2 more lines of code to log some information and basically return the whole collection back to the client. So writing those Azure functions, I realized that I'm writing much, much less code. So even in this last example, I will switch back. To achieve this, to pull the data from database and return it back, in a normal application, I would definitely need to have some repository level. I will access my database, I will pull all the data, maybe I will map it, because I have my entities, and then I will have data transfer object or whatever. I will map it, and then I will return it. And with Azure function, I basically use 2 attributes and 2 more lines of code to return all this data. And this, first of all, saved me a lot of time, and I don't need to write all this infrastructure. I just wrote it my business logic, and I was able to start working with this right away. And let's do basically a demo, and let's have a look on how those Azure functions actually implemented. So as I said before, we have a create movement function, and I'm using the output binding for this, this one, documents out. So I will generate some test data on here line, and as you can see here, there's nothing special is happening. I just have my test data, which is basically hard-coded. So I'm generating a model, I'm returning it back, and I'm adding this to my collector, async collector. So when my Azure function will finish execution on this line, those data will be pushed automatically to Cosmos DB. And here I will just specify the amount of items I want to generate because it's kind of random. And to calculate our stock, as I said, I will use the trigger to react on any changes. And another thing I want to mention here, what I can do in this case, I can also specify another binding here for Cosmos DB, output binding, which will be exactly the same as here, but with different container name. So I can also insert this binding here, and when I will finish creating of materialized view, just save those documents, and I will be done. But I just wanted to show that there is another way. You don't have to do this always with binding. You can do this in a way as you like. It's just that you will need to write some code to actually connect to your Cosmos DB. I need to specify the container name I want to use, get my database, and get the container I want to work with. And then I can do basically the same operations. So I'm checking if I already have materialized view or not. I'm doing some business logic, and I'm saving my data in Cosmos DB manually. So it will happen in the middle of execution and not in the end of execution of Azure function. And get storage location, as I said before, just 2 more lines of code to log some of the information I have and return basically everything what we pulled from this container. You can do a bit more with that kind of bindings. You can also specify an ID of the document, and it will basically, if you know your ID and you know, for example, partition key, it will return you only one document because it will be point read. And beside this, of course, I'm always losing my mouse from time to time. Besides ID and partition key, you can also specify an SQL query if you have no idea like what exactly you want to get, but you want to get a collection of items filtered, maybe sorted. You can also do this in a query. I personally am not a big fan of writing queries, especially in attributes, because it does look like magic for me. But I just wanted to show that there's many different ways how to work with those bindings. And at this point, let's go back to a presentation and have a look on the other Azure functions we can have and what we can do with them. So as we calculated our stock and we were already able to write some movements, what we can do as well is to build an Azure function to return some information which needed for our client to connect to Azure SignalR service. So in this case, I'm using HTTP trigger and SignalR input binding. So it will pull a service URL and access token, and it will return it back to our client. So it will be able to establish a connection through a WebSocket and basically receive some messages. And another Azure function, which we'll also see later on, is with Cosmos DB trigger and SignalR output binding. And in this case, I want to notify my client every time when there is a change happening in my stock. So I would use this function for this like monitoring application where I will have a huge monitor in my warehouse. And every time when there is a stock change happening, I will send a message and I will display it in those monitors that we sold some items or we received some more items. So that's basically the idea why I want to have this function. And to see how our client could communicate with like Azure Functions, SignalR in general, just one more time, we will see this. This will be our React application. We will see it a bit later. So what I will basically do, I will send a request to my function app, to my, I will have a URL of my function app, and I will send a request to API/negotiating point to receive information about Azure SignalR service. And once my client will get all this information and establish connection with Azure SignalR, I will be able to listen to some events when I will subscribe to them, of course. And every time when the change will happen, I will have another Azure function, as we saw before, which will be connected with the output binding to my SignalR service and will send the messages there. And once they are received, they will be broadcasted to my client from Azure SignalR service. So this is basically the structure how they can communicate between each other. And to have a closer look in the code, I will use a SignalR package for like JavaScript clients, and using Hub Connection Builder, providing the URL to my function app where I know that I have this negotiating point, and starting my connection, I will be able to establish like WebSocket connection between client and Azure SignalR. And after that, on the same connection I will be able to say, I want to listen to a specific event and process my event like with function or action, whatever I will have. So it basically looks super easy. You can just you establish a connection, you say on a specific event, do this thing. So in my React application, we are really close to the second part of the demo. I will use React, of course. And another thing, maybe not everyone is familiar with, it's a MobX-state-tree library. This is an alternative for Redux. I use it because it helps to organize the application state in very, very structured manner. And I do like to use it because, first of all, it's super simple, especially for small applications or like internal tools. It speed up like development process significantly for me. And I will just name 3 reasons why I like to use it, and we will go to a demo part. So first of all, I do like it because it has centralized stores of my data. So I have an object which contains the description of how my data will look like and how it can be mutated through some actions. And then there is another section which called views, is basically if my component want to have my data transformed in a different way, I would not do this on the component itself. I would not mutate my data or change it or reorder or whatever. I will do this in the centralized place. I will maybe format my data, and I will allow my components to consume it. Another thing is that data is easy to use, but it's protected. So you can mutate your data. It's mutable, but it can be mutated only through specific actions, again, in this centralized store. So you will have a section with different methods, and your data will change and components will be re-rendered only if you will do this through those actions. So I like going from a .NET Word. I really like it because it's kind of like some encapsulation of some of the functionality. The simple assignment would not work, and I would expect this behavior because when I work on backend and I assigned my data, I don't expect it to change in database directly. So I would expect the same behavior on a front end, that if I just assign my data, nothing will happen. But if I will go and call like specific action, then my data will be changed. And this is what I really like about MSD. And it has a built-in support for references, so we can easily normalize our data across the whole application. So we basically have stores, and we can inject them in the components or each other and reuse them. So demo part, the second part of the demo, I want to show again those two Azure functions which I haven't showed before. The one will be used by our client to receive information about Azure SignalR service. And here we will have SignalR input binding. And if you need more information except hub, because we will send messages to our client will establish connection with a specific hub. Basically, every time when we will send message, we will need to send it also in the same hub so our client can receive it. If you will send messages to a hub with a name like general, our client will not see it because it will be subscribed to a hub with a name warehouse. You can also provide here a bit of more information like ID token or user ID, climb type list. Like if you need a bit of more security, more functionality, you also can do this in here. And when your client calls this endpoint, it will receive all the configurations needed to establish the right connection. And stock change trigger, as I said before, we will react on changes in the stock. We will use these input documents we received, and we will send them using SignalR output binding. So we will generate the messages, and we will send them to Azure SignalR. I will use an event name called stock per location changed, and we will see that in my client, I will be subscribed exactly to the same event. And talking about client, let's then have a look how it's implemented on a client side. So as I already said, I will use a SignalR package with a ASP.NET/SignalR. And using a hub connection builder, I'm providing a URL to my function app where I know that I have this negotiating point. And I'm establishing a connection. So I do have a bit of more functionality, like how much time do I need to retry? What if I, sorry, what if I lost, I need some water. What is going to happen if I lost my connection and so on and so on. So this is one method which will establish the connection between my client and SignalR service. Another method I have here, which basically will create a subject for me. So it will be, I will be able to observe it like from multiple places, and it will return a stream, an observable stream, where I will be able to subscribe on a specific event. So this is not a subscription on the event itself, but just a stream, and then I can subscribe in a place where I want to do this. And as I mentioned that I'm using MobX-state-tree, this is basically the syntax how you can specify it. So you have an object, and you have the model. I don't have any model in my socket object, but I do have those actions. And every time when I want to do something, I will call the connect to socket or get stream action. So I have another store, which is called home store. Because I will have only one screen, this is basically the only place where I have any kind of logic. And I have an action here and method called after create. And this is an event which will be automatically triggered once my home store is basically created. And there is a couple of more you can use as on patch or on snapshot. If your data is changed, you can also do some actions afterwards. It's basically like a life cycle of our store. So when my store is getting created, I'm establishing a connection with Azure SignalR service, and I'm getting the stream for this event, and I will subscribe on it. So after a subscription, if I will receive some messages, I will process them in a specific action, which I have implemented higher in the same file, this one. So this basically, while I will receive a stock data, what I will do, I will just go through those items, and I will find out if it's a new item, or I just have to update what I already have on my UI. Beside this, I have two another functions. The one will call my Azure function and will generate some random movements. And another one to get all my storage location. So basically 3 functions what I will use on my client. And going to a component, just having a quick look. So this is my home component. I have a home store I'm using here. So I'm injecting a home store in my component. And what I will do here, I will just pass my data, which I will receive from calling get storage locations in point, and I will pass it to my child component. So my child component will not call any service, will not do any logic. It will just render what is received, basically. And when my home component will be rendered, I will get this information. And I also have some functionality to start an interval. So I will be able to generate some random movements every like half a second, just to show how the real time basically works. And I'm pretty sure that it's already up and running. Yeah, that's true. And now we will go to a browser and actually have a look how all this thing actually works. So now we have here a Cosmos DB Cosmos database, and I have a couple of containers created here, but they are empty, nothing in here yet. And this is my client. Yeah, so nothing is here. I will generate just a couple of movements just to show how those items will look like in my container. So if you saw, there is a gap in between, because when I clicked create movements, the movements were created, but it also takes some time for trigger to be executed and create materialized view and save them again to another container, to stock per location. So we have 5 movements which were generated, and as you can see, it's just a plain, basically, object which contained the article ID, the name of it, from which location and to which location my item was moved. And for stock per location, this is basically the same information we can see on UI. I have a location name, and I have a list of items which are on this location. I do have some negative numbers. This is happening because we have because my test data, I'm basically trying to move some water or cola from the place where they never existed. But for the warehouse system, it's also the case that you might have those negative numbers because you don't want to hide that something disappeared. You want to know about this problem, and you want to react on this and find out why does it happen. So now, as we saw how the items can be generated, I want to go to my stock change trigger, which is basically the one which will react on our stock change and will send the messages to SignalR. I want to connect to it so we will be able to see how fast the messages appear in the portal and on our client. So it will be basically in the same time, like simultaneously. Yep, so we connected. And now when I will trigger this interval, we will start generating new movements and receive messages on the UI. again, we have a bit of gap between when the movement is created in a database and is actually and materialized view is generated. But as we can see that actual changes when they received by Azure SignalR, those messages broadcasted to my client, and they appears here even faster than they are in portal. So we can see that it's happening really, really fast. And basically, that's the way how it works. So now, as long as I will generate some random movements, and I know that my SignalR service is up and running, I will receive those updates, and maybe I will stop it now. I might receive a couple of more messages. So this is basically how my client can communicate with Azure SignalR through Azure Functions. And just to have a quick look, what I want to small comment before I will wrap it up. I have those functions in here, and if you want to debug it locally to play in the same way, so I have it published on Azure, but I do have my local client, but I want to play around, you might have a problem that with CORS, and you have to go here and basically specify your local host, like your client address. And for your functions, another thing, don't forget to go to your SignalR, get the keys, which is connection Azure SignalR connection string, and put it in your configurations for your functions. It was, I don't know why, but it was quite common. I saw in the last couple of days that someone was forgetting to put some connection strings, and that was the reason why debugging process was not happening, or testing process. So don't forget about configurations, don't forget about CORS, and yeah, in any other case, it's super easy to play around. And just a quick summary from what basically I learned and from my experience from like putting this all together and working with Cosmos DB and Azure Functions, they allow me to write much less code. And this is the great thing is, because besides having less code, I also can save some time, and I can concentrate on my business logic much more than putting around the whole infrastructure and thinking like how my data layer should look like, what kind of services I need, and so on and so on. And also, it's super simple to build the separate components. Not only that you have everything separated because in separate Azure functions or function apps, but also it allows your team and other developers to even listen into the same container and being subscribed on the same events, work independently, and build different materialized views and basically separate your logic. And at this point, thanks everyone for listening. And once again, you can contact me on like LinkedIn details and on Twitter. And I'm looking forward if there's any questions.
Great, thank you, Olena. Let me just bring myself back in here. And I should actually say Djakuju. I think that's how you say it, right?
Yes.
It was hervorragend.
Yeah.
All right, cool. We do have a couple of questions. Let me just find them. So first of all, I made some notes. First of all, and I'm totally not into all that Azure, universe. But
yeah.
One thing that always surprises me is if I go to the Azure portal, I'm like stunned about how much services there are. And I just wonder how do you keep track of that, and where do you actually start?
I will be completely honest. I started a couple of months ago. I hated Azure before. Like I was not working. I was like, no, I'm not going to look into Azure at all. We started to work because we were searching, as I said, like we started to build warehouse system, and the companies, both of the companies, they're quite big, and we had already like 20, 30 warehouses. So we needed something, first of all, scalable and maybe globally distributed. So we kind of get this idea to have a look in Cosmos DB. And once I started to look into it, it's kind of, getting step by step. Okay, there's Azure Functions, there's change feed, but what if you need to do some aggregations? Then you look in Apache Spark. And with time, you just kind of getting used to it. and every time there is like some new things, is like it's easier to keep track of like one or new service which was like released if you already learned everything before, so it just takes time, like a couple of months, to actually get into it. But I agree, it's pretty big.
Would you say it became is it in between love-hate relationship, or even more love already?
I would say, it's kind of, I'm impressed from the size and variety of different like services, features, and so on. But I still in love in writing code. Like I feel sometimes lazy, but I really love writing code and all this like .NET thing. So I love that they makes our life easier, but I don't really like Azure.
I have to say, and I bring this up the second time already today. I have to tell like everyone, it's the first time I was working with telemetry over the last past 2 weeks. That was really interesting and took also not so much effort. Yeah. Okay, but we do have a couple more actual questions to the talk, right?
I've got a very simple one to start with. Is the sample code, is the code you've got there, is that available on GitHub?
It is. I do have sorry, I keep forgetting to put it in my presentation in the end. I do have it on a public GitHub. Just if someone's interested, just write me a message in Twitter. I will send it.
Sure thing. If you give it to us afterwards, then we can perhaps put it on the in the comments of the stream
of course,
well.
I will do
that'd be useful, because it'd be very interesting, very useful to be able to sort of go through the code and
yeah, there is everything in one repository basically.
Mm-hmm. Great. So this is the code that you're showing today. Is that based on production code, or is it a sample which you built just to sort of show how everything ties together?
It's definitely not a production code, but because I was investigating mainly all this like Cosmos DB and Azure Functions and so on, the way how we're building production code quite similar to how I'm building my demos, because well, I'm kind of also building the production code in the end.
Yeah, sure.
I'm trying not to build it in the same way, because of course production code is much more complicated. There's many edge cases and so on. But the general idea of kind of the design, how you have those Azure functions, how they communicate, is pretty similar.
Yeah, because what interested me really, I guess, is because you're sort of creating something new here. I was wondering if you were creating a new feature or migrating existing code. So, what did you have before, and what have you got now, and what were the sort of problems you hit along the way there? Because this looks like a very I don't know what would be the word. It seems to be a really good way of solving this particular problem. The Lego, as you say, the Lego pieces, they fit together very nicely, and yet a solution which you build yourself, a previous solution might not have been quite so Lego-like and clipping together. So, what problems did you hit along the way?
First of all, this code is completely new, and we are not migrating anything. So we, of course, the way how the warehouse function inside, we kind of need to take the same requirements and in the end build more or less the system which will behave the same. But we don't reuse any parts of code and so on. I don't know why, but somehow it's always the case that if you have like warehouse system or like some retail system, it's always legacy. So we don't reuse it. It's legacy. That's the reason why we're rebuilding this, because it doesn't really scale well, and especially during the merger now it feels really well. So all those pieces are new, and they just based on the requirements and business logic, basically. So it's not even the same structure how those pieces are with what we have now in the old system. It's not the same.
Okay. One of the things I was wondering about with the SignalR connection was, does that mean now you can have sort of multiple connections as well there? So it's not just a SignalR connection to a single instance there, is it?
No. Yeah, of course. You can you can have multiple clients connected, and for me, for example, it was never a case that I want to connect to a specific user or something like this. But it's pretty flexible, this connection. Yeah. So if you saw there's like a hub name, so you first of all you can change it dynamically. You can for example, if I have a couple of warehouses and I want to have a different tabs and see my stock for all the warehouses, by just clicking between them, what my client will do will just reconnect with a different configuration, for example, and will receive messages. And the same will be for other clients. They can be connected to the same hub and listen to all those messages, and they will be broadcasted to all of them.
That's really nice. I like the sound of that. That makes it sound nice and straightforward. Just swap connections, and you're working with a different warehouse and everything.
Yeah, it's this is all like this sounds like really straightforward and so on, but sometimes when I'm realizing that we will like grow our warehouse system and so on, I'm kind of a bit of afraid because it's all kind of on triggers and events, and like it's all I kind of a bit of afraid that it's in the end could be a mess. So it's also like you have to pay attention not to overwhelm your system with all those like triggers and events, and really kind of think through. Like we really spend a couple of months just thinking and constantly discussing about all this infrastructure, because once you know how to do this, it's easy. But if you start building and start thinking, of course your design is changed, but if you have no idea at all, it will just end up with tons of triggers and clients listening to everything, to everyone, and it will be just a mess in the end.
That leads on to another question, actually, which we've got, was how easy or difficult is it to debug Azure Functions and all of this, and especially if you got all the triggers and that, and the question I think is dealing with React as well. So, I guess two parts, how easy is it to debug with all these different triggers and everything you've got there? And then how well can you do that with React itself?
Well, so debugging, you know what? I just had the same question before yesterday from my colleague, like, how do you debug these things? And to be honest, I don't really debug them much because building, like, first of all, write tests to cover the business logic. It's the first thing. And another thing, because they are kind of pluggable, there's many ways how you can test them. So you can test them directly from Portal. You can just trigger this function, see if it works. You can run them locally. You can also run attached to basically a process, and then you can debug them. But I do know that sometimes people have problem. I was able basically without any problems to attach to the process when I run this Azure function and just go through it. But the most of this demo, I was not debugging at all. I just wrote a code and it was working because the whole code was migrating from different demo, which I built previously. And it was before a console application. So it was already tested quite heavily. But it's not a problem, should not be a problem to attach to a process of the Azure function and debug it. With the React, this is a good question. I actually don't really know how you can debug your front end at all. Console log and console information. No, but without jokes, first of all, if I have if my API works properly and I know that I'm receiving the data and my client can receive everything that is needed, is it from Azure SignalR service or whatever, the only thing you have to do is to ensure that your client has actually received it. And I'm using MobX-state-tree. It's super easy to actually understand where it's going with your data because you basically can open it in browser and expect the whole tree. I don't really do this that often because it's not a debugging. It's just observing the state of your data. But yeah, if I need to debug, I debug it in browser, to be honest. I don't have any special magic how to do this. But I do work a lot with React. So basically, most of the things, if I debug something, it's I messed things with the configuration or something like this. So something is really bad and it doesn't work.
Yeah, okay.
We have another question from Frederick, which asks a pretty interesting question. Could have been me. Do you ever worry that an event trigger would end up triggering itself, causing infinity loop, causing a lot of costs?
Yes. I also was thinking about it because that's exactly what I said before, that it's really, you should be careful with all those triggers because you can end up in a mess. I do worry about this, and before implementing any part of the functionality with all those triggers and so on, we really think through all this, how it's going to be implemented. And also in the production code, we do implement how deep you can go. And well, basically in the production code, we do have some functionalities when we go in the tree of the items. We do have some tree structures in there. And we also handle like how deep we go in the loop and if we're really not stuck in there. So of course I do worry about it. And we actually also had a lot of discussions about it recently.
But isn't there, I just wonder, from side of Azure, would there be any way to have some heuristics or something like that? That would like...
Good question.
Or is it just that you set a budget and that's it?
No. Good question. I think I never checked Azure. It's actually a good thing. I will do this afterwards. But I'm pretty sure that they should have some functionality to actually stop this. If it's like stuck, it should be like, for example, if I use Cosmos DB and I imagine that my trigger like stuck in the loop and it's like writes data and triggers itself and so on, what I will have for sure, I will start having a hot partition in Cosmos DB because it hits the same server, for example. I will get a hot partition. So it will be one signal that something is going wrong with my Azure Functions. But if there is something with Azure Function itself and triggers, this is a good question. I don't really know. I will need to have a look in it. Good question.
I would expect there might be something.
Yeah, I would also expect it, that's for sure.
Yeah. Eldad, I hope I pronounced that correctly, also has a question, and it is, when would you use the bindings and functions, and when would you use the SDKs of the different services instead? For example, for Cosmos DB. Yeah.
What was the first part?
When would you use the bindings and functions, and when would you use the SDKs of the different services instead?
In the different services. The SDK for different services. Well, what kind of different services? It also depends on what service are we talking about.
I may ask that, and we might come back to that.
Yeah, it's actually it's the bindings and functions. I think that yeah, it all depends on the service itself. Like I would use a binding for sure if I need to have something really simple. Like in general, what I have to say, like working now with Azure Functions, I would try to keep Azure Functions super simple. Like I was showing before that you can specify ID and partition key and even SQL query with Cosmos DB output binding. I would not do this, to be honest. The maximum what I would do, ID and partition key, okay. But if you have to write a SQL query, I would not do this in the binding. It does look like magic. It brings a complexity in the code, and it makes it hard to understand. Especially, I would imagine the new person coming in, having a look on a attribute, and there is a query in it. I can imagine the reaction, like, how does it even work? So I would definitely go with binding. If I need to pull some simple data, like everything what I have or one specific file, I would use binding. If I cannot do this with binding, I would definitely go and implement my own logic for Cosmos DB, for example, as an example.
Mm-hmm. Also, I have to say those bindings look like perfect food for source generators or something. But I don't know. I guess it's useless there. I'm not sure.
If only we'd had a conversation. If we'd have a session about source generators today. It's great. Speaking of the bindings and the parameters, though, I noticed one of the parameters was a collection of dynamic. We don't see much use of the dynamic type around. How come you're using dynamic there?
Yeah, actually, this is kind of by default, and this, to be honest, the same for me. I think that it was like first time in a long time that I saw dynamic type, and because first of all, Cosmos database is multimodal, so it's not only document; it can be graph, key value, whatever. So I think this is the reason why you have dynamic. But if you know that you're working with the documents, yeah, I think that you can also specify the document type itself, and it would be all right. But because of multimodal and all this, you cannot really predict which exactly type you will receive in the end.
Right, that makes perfect sense. Yeah.
Yeah, it's also not the case that you don't know which database you are connected to. So I'm pretty sure that you can specify it in there.
Yeah, true. We had another question as well, which I think is a perfect setup for us, to be perfectly honest. It says, how do you work with Azure Functions? Do you use the CLI, or is there an extension in Rider for that? And funnily enough, there is an extension in Rider for that.
It is,
and,
yeah.
Yeah, we can. It's Martin, who's been on the stream earlier, works heavily on that. He's involved in that, as are several others around here. Yes, you can do a whole bunch of things. You can add sort of run and debug markers into your code, so that you can sort of click on a code next to it and run and debug against the emulator. It's got the storage emulator built with it. And generally just makes working with Azure Functions a bit nicer. So if anybody out there wants to try Rider with Azure Functions, make sure you get the latest version of the plugin as well. So that was a nice plug. So sorry, that wasn't even a question for you. I apologize.
No, that's all right. That's all right. I to be honest, I started to work with Rider maybe 1 year ago. No, 6 months or 9 months ago, because I was working on Windows machine before, and of course like Visual Studio. But then I switched company, and my colleague he advised me to start working on Mac, because we do develop like .NET Core and so on, so you don't need to use Windows machines anymore. And he advised me to try Rider because it's much faster, and especially we had like microservice architecture. And if you wanted to test, for example, the flow or try some things, you have to have a couple of instances. And for like with Visual Studio, it was quite like heavy, and it was not really working as expected. With Rider, everything was flying, and I really liked it. So now I do work with Rider most of the time.
Well, we won't argue with that in the slightest.
That was a nice compliment.
Yeah, we'll take that.
Good. I'm happy that I can make a compliment. It's really, really great tool. I do like it.
Great. Matthias, do we have any more questions?
Please tell me if I just didn't get it, but we have one more on our list, which was a more general question actually. Do you have any recommendations on when an application should receive like real-time updates, or is there really only like specific use cases, like I don't know, we have stock markets here and such like that? Or when exactly do you really rely on this fast real-time update?
I will definitely, I had a couple of use cases before as well. I would definitely, if you have any functionality of collaboration, like it was from my previous experience of working where you had in a browser a mode of collaboration when two people can come in and change things. This is, of course, the real-time functionality for sure. For any kind of monitoring, so like in our product company, before I built also UI, which would really would be the real-time functionality would be a great fit. When you saw in the real time the assignment, when we had an order and the order is ready to be delivered, it would be assigned to a specific driver. So that kind of functionality we wanted to have in real time, and we had a dashboard for basically to see how it's like going, like which driver is picking which order. And I would say that any type of monitoring collaborations should be in real time. Otherwise, just ask yourself if it's not easier to just query it every 5 seconds or something like this. Yeah, because sometimes it could be a case. If you don't have to do this all the time, have it in real time, and like at some point of the day, couple of hours, you need to have it real time, and the rest of the day no one is interested in this functionality. Maybe it's easier to play around and actually implement some like just pull in.
Mm-hmm. Gotcha. We have something actually that kind of leans into what we already discussed when we were talking about this. Really, when you said you're really careful about introducing new triggers, and so that they don't trigger each other. The question is which functions. Let me just read it. With functions triggering on events in other systems, how easy or hard is it to keep track of the overall application architecture? Is there a way to get an insight into what function listens to what event and what functions emits events?
What functions emits events and listens events? Then every time when there is events, there is kind of like a bit of like magic, because you cannot really easily like check it. The first of all, like how we handle it and how we understand it. In any architecture, if you build a microservices, I would also like ask how you keep track of all those like microservices and all the functionality. Exactly in the same way, we do have also like microservices, but it's just like our function apps. And the separate teams take care of the like each service. to trace the whole, like, to have a trace of like every trigger and every event. We don't have it yet, and I don't know if there is anything default for this, but I'm pretty sure that like any production system will need to implement some like advanced log to understand like from which servers the event was sent and who consumed it, basically. Yeah, so I don't know default functionality for this. Definitely something which is needed in the production code.
Okay, cool. Yeah, someone also just mentioned application insights, telemetry, all the things.
Yeah, application insights is true. You can enable it, but I don't know. It was not pretty helpful for me, to be honest.
Okay, I don't have any more questions, except maybe one, but that's very off topic. I noticed you're pretty new in the speakers profession, let's say. It's like you're, I don't know, I think I saw your first talk very recently.
Yeah, I started like months ago, I think. Months, 1.5 months ago, I started speaking. So cool. Yeah, it's like, I think that this is like my first conference itself, because before we had like more meetup. Oh no, there was like Azure CosmosDB conference and Global Asia. But yeah, it's kind of all new for me, and always, exciting. It's a bit nervous, but I'm trying to, my goal is to share just like my pain, my experience, my things I'm doing in daily basis. So, and I'm always happy when people are also interested in this, especially for questions.
I think you definitely reached your goal today, and I hope we did a good job providing here a good way and experience for you.
Yeah, actually, really great experience. I really enjoyed this.
Cool. Matt, do we have anything else, or should we?
No, I think we're done. I think it's time to say thank you very much. That was a great session. It's surprising to hear that you're so recent in this. It was great. Thank you very much for joining us.
Thanks a lot for having me. It was really my pleasure.
All right, then. Great. See you around. Olena,
see you. Bye bye.
Bye bye.